Hi, my name is Jordan McStay, and this is my presentation on the circulatory system. I have two sheets to help us learn about the circulatory system today. I'm going to start off with this small one. We're going to go back and forth. And I want to start this whole system off starting at the artery. I'm sorry, the aorta. The aorta is where blood exits the heart and enters the body. The blood is oxygenated blood, and it travels to upper and lower body parts through things called arteries. Some of these arteries are known as the carotid artery. We have the mesenteric artery right here, the renal artery, the iliac artery down here. Now, once the arteries hit the venules, which are right here, will transport the blood into the capillaries. In the capillaries, that's where we see oxygenated blood turn into deoxygenated blood. The deoxygenated blood then exits the capillaries at the arterioles, which we find over here, and now entering the veins. Veins carry deoxygenated blood from the capillaries back to the heart, where it can be then oxygenated at the lungs. Some of these veins are equivalent to the arteries, but they're veins, like the iliac vein, the renal vein, the hepatic vein, and the hepatic portal vein. And then we have some upper ones, the jugular vein up here. And we also have capillaries at the top as well that are also deoxygenating blood. Once the blood gets back to the heart, it's going to enter the heart from the upper body through the superior vena cava, and it's going to enter the heart from the lower body through the inferior vena cava. And this is when I'm going to switch over to a zoomed in version of the heart. Now, the blood is now entering through superior and inferior, which comes up and around here, vena cavas. They are then entering from there into the right atrium, which is found right here. This is where the SA node, also known as the pacemaker of the heart, sends electrical signals to pump blood from the right atrium through the tricuspid, which the tricuspid is going to prevent blood from backflowing. It'll only have the blood go through one direction, into the right ventricle. Then, as the blood enters the right ventricle, the AV node receives a signal to act as the getaway to the right ventricle and control the speed of the blood flow. That way it's not too much blood, not too little. It's exactly how much blood the heart wants to go in there. The right ventricle will then pump blood through your pulmonary valve, which is found right here, into the pulmonary arteries. Now, a fun fact about the pulmonary arteries, it's the only artery in the blood that's carrying deoxygenated blood. Now, the pulmonary arteries are then going to bring the deoxygenated blood out, and we're going to switch back to this one. And up into, right here we have the pulmonary artery, into the lungs. There, the lungs will send this deoxygenated blood into the capillaries, where it is then becoming oxygenated by sacs that are holding oxygen we breathe in. This then oxygenates the blood, brings the blood back through another lung down to the pulmonary vein, the only vein in the body that carries oxygenated blood. This then will bring the blood back into the heart, and back over here, back into the heart through the pulmonary veins into the left atrium. Then the left atrium is going to push the blood through the mitral valve, which also keeps blood from back flowing, into the left ventricle. The left ventricle will then pump blood into the semilunar valve that then brings the blood up through the aorta back to start all over again.